In the last video, I showed you how to build a little vertical cantilever model in the mastan software and analyze it under a lateral wind load, and we saw that that gave us a bending moment diagram that was much like the shape of the Eiffel Tower. In this video demo, I'm going to show you how to get some insight into the behavior of arches. I have mastan open, again with a blank modeling window here, and I'm going to start by defining geometry. All right, so I'm going to define some nodes here. In this case, my first node will be at 0, 0, 0 again. My next node is going to be at an x-coordinate of 120 inches. So node 2 appears over here. And my third coordinate is going to be up here, kind of above the 2. And so it's going to be at an x-coordinate of 60 inches and a y-coordinate of 20 inches. And I'll apply that here. So we see that node 3 has appeared. I want to connect all of these with elements. So I'm going to make first element from node 1 to node 3, click apply, node 3 to node 2, and click apply, and leave it at that. So these are two elements that form a triangle, which is sort of the simplest form of an arch, really. And I now want to define section properties. I'll use the same ones as I did before, a cross-sectional area of 3 inches and a moment of inertia of 1 inch. I'll click apply and attach this section to both of the elements I've defined. Success. I'll define a material, which will be steel again, with a 30,000 KSI elastic modulus, and a weight density of, actually I'll leave that at 0 in this case, and I'm going to apply that. So material 1 has been defined, and now I'll attach this material again to both of the elements, click apply, and those elements have both turned to solid lines, meaning that they have material and section properties attached to them. I need to support this, and I'm going to make this a two-hinged sort of arch. So under define fixities, I'm going to select the two abutment nodes, node 1 and node 2, and I'm going to restrain them against x displacement and y displacement, and leave all of the others free. And this x and y displacement restraint or fixity corresponds to a hinged support, one that's not free to move in either the x or y direction, but is free to rotate. And we don't have to worry about the z direction because we're building a two-dimensional structure here in the xy plane. So I'll click apply, and you see that red arrows appear to indicate those fixities. I'm going to load this arch in a fairly simple way, since it's a simple triangular arch instead of a parabolic arch. I'm just going to give it a point force under define forces. So that was conditions define forces. I select node 3, and I want to put a downward force of, say, 1 kip in this case. So that's 1,000 pounds. And to make it go downward, I have to put a negative sign in front of it. I'll click apply, and you see the green loading arrow has appeared there. Well, I'm ready to run my analysis now. I go back to the analysis menu, first order elastic. I can select space frame again here and click apply. And I get an unstable structure error. So this is an error that will come up from time to time. And what happened there that caused the unstable structure error is that down here I forgot to select planar frame. I selected space frame, which means a three-dimensional structure. And I'm just analyzing a 2D or planar structure here. So if I choose planar frame and then click apply, I get success, analysis complete. So we can look at results now. If we go to diagrams, deflected shape, and click apply, we see very small deflected shape. All right. There's this scale factor down here. It's set at 10 right now, which means that the deflections are being exaggerated by a factor of 10. If I increase this to 1,000 and click apply, you can see deflection. So the point here is that arches are very stiff, and the amount of deflection is very, very small. All right. We can look at diagrams and moment z. Remember, that's what we looked at for our vertical cantilever, and click apply. And we see some bending moments appear here in the arch. What about the axial force? So an arch is really meant to work primarily in kind of axial force mode. And if I choose axial force here and click apply, I see these bars come up. And again, if you click this fill button, the diagrams turn out to be a little bit more appealing. So in this kind of diagram, the red indicates compression force, and the width of the bar indicates how big the force is. So you can see that this structure is acting in compression, and the load path is such that this force flows down the members to the abutments. So that's basic arch behavior.